Okay. Well, let's take a look at this. So yesterday I saw, 16 hours ago, yesterday evening I saw basically Twitter blowing up because this post was shared on through the Swift forums, and it's basically the Swift core team take on Swift's concurrency and basically what's the roadmap to get some sort of concurrency in Swift. So what's the deal here? So what do I know about Swift concurrency before this? So a while ago, Chris Latner made kind of a manifesto, I think it was, basically outlining what his thoughts were about how Swift should tackle concurrency. Of course, we saw things like async await, which is nowadays common on any modern language, from JavaScript to I think C# was kind of the first ones introducing that. But basically, that modifies the language, incorporating a new type of function that can basically pause and be restored after the fact. Okay, so you're gonna start doing some code and you stop the execution here, you do something else, and then you come back after the function that you yielded to, which is I think is the word they use. So basically you're waiting for a function to finish, and when that function finishes, it comes back to you. The point, like, that's what normal functions can do already, but the point that this can happen kind of synchronously in different threads or whatever you need to implement. And for me, reading that manifesto from Latner, I think that was the most exciting part about it. It was not the keywords, it was not the fact that we seemed to have concurrency in Swift closer, even though it was not the case. That was just a suggestion years ago, and it has taken until Swift, when it's going to become Swift 6, I assume, to get something on it. So the exciting thing, it was how he envisioned the layering of what you need to get concurrency. If I'm not mistaken, often what other languages have done, they have built what is the concurrency primitive. They have been built in a certain object. Okay, that means I think on C# they use the task object, which is basically an object that encapsulates kind of work that needs to be done, and then you can dispatch that in some sort of thread or whatever it is. Kind of like our operations or NS operations in Apple's frameworks, basically. So I think that language starts with that, and then when it incorporates the async await keywords to make the usage of that, basically it's like syntax sugar on an object specific system. Okay. I think if you look at JavaScript, they do the same thing with promises. So promises is the asynchronicity system that you use, and then they just added async await, basically the keywords, to make it nicer to use. Maybe mistaken, but I think that's my kind of my understanding of it. So the twist here that Latner kind of talked about was that they wanted to inverse, or at least he wanted to inverse this layering. So instead of making the objects the core of the system and adding keywords on top of it, he wanted to inverse that and make the language, so Swift the language, just support coroutines basically. And coroutines are often used to implement concurrency, but they also can be used to implement other kind of iteration patterns like generators and stuff like that. So the idea was to put on the language itself the primitives needed for tackling this, like the engineering needed for the language to understand that you wanted a function to yield and then come back to that function, which is basically like what a kind of a coroutine does, as far as I know. I'm not an expert on any of this, especially because I haven't used a language with async await. I've used C#, but not that much, so I'm not an expert on what's behind the scenes. But that's my understanding. And then on top of that, so the language only knows how to deal with coroutines. Now, asynchronicity and the proper APIs for you to use, that's not the problem of the language. Then we will build libraries on top of it that will give you asynchronicity with async await, for example. Or you could build promises on top of it, or you could build, which was very exciting from Latener too, like he envisioned that the end goal of this was, once we started building these asynchronous libraries on top of what the basic language features were, we'll end up at some point getting a proper actor system in Swift, which is a very nice and elegant way of dealing with asynchronous, like heavily asynchronous systems in Swift. So that's what happened. I don't know, 1, 2, 3 years ago. I don't know when that manifesto was raised. And now we have this concurrency roadmap. At the beginning of the year, the Swift team, I think I even made a post on my blog about it. The Swift team basically said, this is what the next steps for Swift are gonna be. And that's what we're gonna be focused on. And one of these things, let's see if we can find it. Road to Swift. I think I was this guy, right? Yeah. Road to Swift 6. Yeah. I made a video about it. But basically here you can see they made a post outlining all of this. So one of the themes was basically concurrency. That wasn't one of the themes. So we kind of knew already that we were gonna get sooner rather than later, that we will get asynchronicity, some sort of way of dealing with it natively in Swift. Because we don't have to forget that we already have ways of dealing. We have, if you're working with Apple platforms, you have all the dispatch system frameworks, operations. Now you have combine. So we have a lot of ways of dealing with it. It's not like we are missing something huge, but it's true that in a modern language, not having kind of a native system in the language itself to deal with concurrency, it's kind of a big red flag that a lot of people points to. But now let's take a look at what's the roadmap. So let's read this. I haven't read it yet, so if you know more, if you know something, or you already have more ideas on what this means, because people have been talking on Twitter a lot, obviously, and I'm sure there are already 50 comments. Oh my god, 50 comments already on the thread. So yeah, people already has ideas and opinions, so we will see what they are. So our goal is to make concurrent programming Swift convenient, efficient, and safe. Okay, that's already super interesting. And again, yeah, I'm probably getting too excited about this. But convenient, probably this is gonna mean async await. And maybe I talk a little bit about my opinions on that. Because it's not the panacea, okay? Everybody puts it as, oh, new language needs async await, like if that was the holy grail of concurrency, and I don't think it is for some reasons. But maybe we get that. Talk about it later. Efficient, that's also cool because you can build systems like this, but to make them efficiently, it's not that easy. There is a lot of things that you need to get right. And if you look at things like Rust, which by definition their purpose is to be as efficient as possible because they are a system language. They need to replace C and C++. They cannot waste things on making higher level abstractions that are going to consume more resources than necessary. So that's their goal. And if you look at the implementation of their concurrency with things like, I think it's called Tokyo and stuff like that, it's super interesting how they can leverage the powerful compiler to basically I'm not sure if it's zero cost abstraction, but it's super close to that. And that's very, very exciting. It's what you will write manually if you wanted to do something similar, but the compiler does it for you, which is, I think that's the best goal. Probably it will be somehow faster if you took another approach maybe, but if you take the approach that these systems want, the compiler does everything for you in a kind of zero cost abstraction, which is super exciting. But the key here is safe. So I've heard on Twitter some people saying that, yeah, they want to actually make data races impossible, which is like it aligns with the goals from Rust. And for me, basically, nowadays, if you want to run something, or it's Swift or it's Rust. That's my take on it, honestly. Like, these are the two only languages that I think they bring something new to the table that make something exciting, okay? And like, granted, like Rust brings something to the table even more exciting than Swift with its ownership system. Not ideal for every case and for every programmer, but it's something new that has been brought into the mainstream in a way that nobody else has been able to do before. So I'm also excited for that path that Swift is taking in terms of ownership, but that's a whole other discussion. So this document outlines a number of proposal additions and changes to the language to achieve this through the implementation of asynchronous functions and actors. Ooh, asynchronous function actors. So they mention actors already here. Okay, cool. This addition will be proposed separately. Okay, so that's kind of like what I was saying. Like, I guess they want to propose what the language needs and then maybe some high-level APIs on top of it. But they will, in many cases, depend on each other. Fair enough. I mean, that's understandable, I guess. I don't know. I don't know enough. This document serves to join them together. Unlike a manifesto, which might describe multiple possible directions, in some cases, like the document describes a single intended plan for tackling. Okay, that's cool. Because we see sometimes like this manifesto concept is like quite common on Swift Evolution, and sometimes we see manifesto saying this and that, and they don't get anywhere. You know. They are super interesting to read from a getting knowledge perspective. Like, you learn a lot from reading them. I recommend everybody from reading the ones like the ownership, for example, is super interesting. But yeah, they don't get anywhere. You know, like you get somewhere with the proposals. That's where that's where gets us somewhere. So I'm happy to see that they clarify this here. Okay, this is not a manifesto. We're not going to talk about all the possible scenarios that we could take with Swift. No, this is our plan. This is our roadmap, and that's how we're going to be tackling concurrency Swift. Great. Amazing. Love it. So the end of state of these changes will... Okay, so just right at the start, they already tell us what we're going to have. Make asynchronous programming convenient and clear at the point of use. Fair enough. I guess that means, yeah, async await and stuff like that. Provide a standard set of language tools and techniques that Swift developers can follow. Okay, that's super interesting. Like, it's not something to be read slightly, because having a standard set language tools and techniques, that's like, for me, it's crazy, because right now, as I said, you can use everything. Like, we have combined RX, you can use dispatch. Like, they all kind of they have different advantages, so you use them in different cases. Like, sometimes you want just to dispatch and you don't want to use the entire RX system, but you know what I mean. Some more or less they fit onto the same purpose of concurrency. So the fact that we will now have like, if you want to do concurrency, anything you want to do, you can do it with this. Pretty cool. It will help a lot reduce the learning curve of Swift. Improve the performance of asynchronous code through better knowledge at compile time. Okay, that's where I get excited. Because the more the compiler can know, it's better for everybody, except for compile times. Eliminate data races and deadlocks in the same way Swift eliminates memory. Okay. Yeah, see? So in the same way they tackled memory and safety in Swift, like, you cannot do memory and safe things unless, of course, you go out of your way and you use the memory and safe primitives, which they are there for a reason, for performance sensitive code and stuff like that. Things like places where the compiler still cannot get you, which is where the ownership system will help us help the compiler get further with it. But in the same way, if you use Swift as you should, you're not gonna get memory and safety, and that's completely true. Like, since I adopted Swift, I haven't had any issues with memory. The only issues you have with memory is two. If you're interpreting with Objective-C, and there are some weird things in there that I would like for them to... I don't know what they did some changes since the first version of Swift, where things came as optionals, and yes, it was more pain to deal with them, but now they come as like unsafe and wrap optionals unless you annotate them. and that's super dangerous. So those are the only cases I've seen Swift, like normal Swift code crash. And of course, if you get out of your way with unsafe primitives, then yeah, it's your problem. So knowing that now they want to do the same, apply similar principles to basically eliminate data erasure and deadlock, it's huge. Like, to be honest, I was not expecting them to get that ambitious, we could say. I thought they would just take some more basic principle. Okay. So the introduction of the, let me see if you are seeing this. Yeah. So, whoops. The introduction of these features will span multiple Swift releases. That's cool. Like, we don't have to hurry to get these things. Feature will be introduced in broadly 2 phases. The first phase introduces the async syntax and actor types. Okay. This will allow users to organize their code around actors in a way that will reduce but not eliminate data races. The second phase will enforce full actor isolation, limiting data races along with a number of features to allow efficient ergonomic interoperation of actors needed to make the isolation practical. So they are going full actors. Okay. The first phase introduces the async syntax actor types. They are going full actors. Because even in the first phrase, it's not like I was expecting the free space to be, we just add the async keyword. Bam, that's it, you know? Now people can build things on top of it. And then we will build something on the standard library, which is going to be the standard way of doing it. But no. They're going out of the box, free space, async syntax, and actor types. So they think the actors are the way to go. That's a strong statement. And yeah, once you accept the actor pattern, yeah, like it's normal. Like if they introduce async and actor types, people will start using actor types, and you can communicate with them and stuff like that. But then I'm assuming that they won't enforce that from an actor you cannot do weird shit. So yeah, it will reduce but not eliminate, because if people still can do weird stuff from an actor, in the same way that like right now Swift doesn't have purity, like pure functions on the system, because it will be a pain in the ass to introduce at the usage side, I mean. But they won't have that, and yeah, you can pretend that your functions are pure, but like if your way of coding it's making functions pure, you reduce the problems, but you don't eliminate them, because any random function can touch like global state and sorry. So it's similar idea here. We can start using actor types. That will reduce it, but unless they don't enforce full actor isolation, which that's what they say here, like full actor isolation, that really means, yeah, you can only work with what the actor has access to, period. That's it. Communicate with actors and whatever you want, but you cannot reach into things you shouldn't. Once we get there, yes, then data races are gone. Fair enough. Cool. As a roadmap, this document does not go into the same level of detail as will do's proposal. That's perfectly fine. It only discusses features for the second phase, but detailed proposals for this area will wait until after the first phase is better defined. Perfectly understandable. There are a number of other related topics not covered in this document, such as synchronous streams. That's interesting. Parallel for loops and distributed actors. That's also interesting, because it means the actors they are talking about, they are actors running on the same kind of system, the same process, I guess. Many of these features complement what is described in this roadmap and may be introduced at any point. That's perfect, like amazing. That's how you design a new feature. Perfectly fine. That's perfectly cool. So just to unpack a little bit of this. Related things that are not covered. Asynchronous streams. Asynchronous streams basically means Rx or any of its derivatives. And that's that's how I understand it, of course, because an async await system just basically makes you get concurrency or asynchronicity of things that gives you a single event, basically. And reactive streams, Rx, all this family of libraries gives you a synchronicity on a stream of events, of multiple events, one after the others, separated in time. You know, like the typical analogy that you can do is that if you have on your normal programming, you will have a variable that it's an integer and it's just one variable. Or you can have an array that it's a package of multiple of these variables. So the analogy, it's basically it's the same thing. If you have a sync await system, it's a way to deal with one variable, just a sync, like when you add the time factor in it. If you have a stream system, Rx, whatever it is, you have a way to deal with an array of variables that come through time, you know. So that's interesting that they acknowledge that this is a separate thing, but we already have combined for this, so I'm not too worried about that. And to be honest, the majority of things you do are not, they don't need that much of streams. That's why, yes, I think one of the things that people say is that when the language has async await, and that's been kind of proved in other languages, you kind of stop needing that much things like Rx and reactive streams, because the majority of things you just need one event basically, but it's not for everything. Now parallel loops, it's interesting they mention it. Because I don't really understand what I mean. Yeah, they are kind of a different beast, but if they mention it, it may mean that they want to introduce it on the language itself. We have already frameworks like Accelerate and stuff like that help with this, or I think this patch does it already. But yeah, it's interesting they mention it. And distributed actors is what I was saying, that I'm not exactly sure. So yeah, from then I understand that the actors they are talking about are basically actors running on the same process. So basically you can build your application with actors or your server with actors, and then distributed actors is okay, you have a swarm of servers running different actors and communicating between them. So that's cool. Cool. Okay, let's get into the meat. Motivating example. The basic patterns that we encourage for concurrency today are good. We tell people to protect the data with queues instead of locks, and return the results of slow operation with asynchronous callbacks instead of blocking a thread. Yep, that's exactly what we do. But doing these things manually is awful and error prone. Consider the following snippet of code that demonstrates these patterns. So yeah, typical, you have a function, you pass a completion block, and then you use a dispatch queue. You do whatever you want to do, and then once it's done, you call completion. There are 3 observations we can make about this code. There is too much ceremony. Yeah, that's true. It's just calling a function, transforming the result and assigning it to a property. Yeah, it's just like, if you call something, you map, and that's it. That's what you're doing. But because there is a synchronicity on it, it's a lot of pain. Yeah, like what you would like to see here is like self game session dot all players, and then you do like for each one you do a map, and that's it. So these 2 lines are what matters basically, you know. And if you don't have to do all of these and these and these, not only will you get only these 2 lines, but you will also get these 2 lines in a clean way. So yeah, there is a lot of ceremony. The extra ceremony makes it easy to introduce block. Yeah. There is a direct assignment to the self player's property and completion handler. Yeah, which is dangerous as fuck. Exactly. Like this is basically a multi-threading issue just waiting to arise. Yeah, usually, I mean, you need, if you want to start doing this, I don't know, or you use a barrier sync on here, or you dispatch to the main thread before doing this. But then when you dispatch to the main thread, then it's like, well, this completion will run on main thread, which is what you want usually, unless you want to change these completions, and then you start jumping between main thread and another thread. So then you need to pass the queue here that you want the completion to run, and you can see how it explodes in complexity very quickly if you want to do it right. It's crazy. It's inefficient. Several function objects need to be separately allocated. Reference to self, which are used by functions, must be copied into them, requiring extra reference counts operation. Yeah. Like keeping in a closure, keeping self alive requires like more reference count operations than what it will be necessary if the compiler really understood what was going on here. So hopefully all of this gets fixed. And yeah, you need to think that all of this is allocating in memory and stuff like that. That's where things like Rust take on asynchronicity are so much nicer in terms of performance and memory and stuff, because they try to avoid as much memory allocations. It's crazy. Cool. What else? These problems are tied together. Yeah, I like that. As soon as you introduce this, you open the door to many problems. Asynchronous callbacks are always eventually run exactly once. Yeah, but you don't know that from the code. Yeah, I love it. I love how they exactly show you the reasons why we need a better system. Which means they cannot participate in permanent reference cycle. Since Swift doesn't know this, it requires self to be explicitly included. Some programmers respond to it, but yeah, weak self. And unpopular opinion, we use weak self everywhere. Period. I know it's not how it should be. I know in a lot of occasions you are not gonna need weak, and unknown should be used instead. I know it's better for performance. I don't care. If you work on a team shipping a production application that you don't want to crash, use weak. Period. Because yes, maybe right now when you're writing your code, unknown makes sense. But the compiler cannot ensure that. So are you gonna ensure that nobody else in the future is gonna change some unrelated part of the code? Because if they change your part of the code, that's fine. They can see the issue on the PR or whatever and change it to weak. But are you sure nobody's gonna change unrelated parts of your code that are gonna make this crash? No, you can't. So yeah, in my opinion, a safe bet, unless it's super, like, there is places I use unknown, that's fine. But there are places that are super clear that it's not a problem now, and it's not gonna become a problem in the future, okay? Which is a different kind of argument of the typical argument that people use for this. Increases both the runtime overhead and the ceremony of the callback. Since it must be handled, yeah, it's a pain in the ass. Frequent usage function immediately return with self is needed. Yep, making hard to reason the correctness since arbitrary amounts of code may have been skipped. Totally correct. So the patterns shown here are good, but we lose structure and creates problems. The solution to bring those problems into the language. The patterns into the language. Yeah, that's how things are really. Like we want a language to be succinct, small, you know, that it doesn't have a lot of things, and Swift already has a lot of things. People complain and compare it to C++ for some reason. But the thing is that if there are problems worth solving that affect everybody, that's what we need to put into the language, you know. That's why people complaining about these new features that Swift will get and it's getting, I think they don't realize that we are not bringing, well, I say we because I consider myself part of the community, and the community is who's working on it, but it's not me. Like Swift is bringing things into the language that are worth solving, and that's very important. You know, when people complain about a small sugar or syntax change, I'm fine, but nobody complains about that because that's what they like. You see the hypocrisy here. What really matters is things that solve problems. Okay, adding like the property wrappers and all that stuff, that's really solving problems. It's avoiding repetition of a lot of things. And the fact that we haven't explored the full power of it doesn't mean it's not there, you know, because we have been talking through a lot of threads about it, and there are very, very elegant things you can do with it, you know. So it's mainly people that hasn't been participating, which is fair enough. Nobody has the time to do these things. But also people that these things are not on other languages, so you don't really see what can bring to your life, you know. And that's what the initial kind of negative reaction comes from, which is understandable, and that's why I love that the community puts a little more effort on explaining these things, basically. So if you bring these things to the language, you reduce the boilerplate and make the language, make the patterns safe. Eliminating bugs and confidence, it's super important when you are programming, especially in concurrency, because it's one of the hardest things to get right in computers. It also gives us the chance to improve the performance and concurrent code. That's also true. Like once the compiler and the language take ownership of something, then it's their problem to make it performant. It's why you don't want to implement an array yourself. You use the array from the standard library. And if on the initial versions of Swift it was not super fast, you don't have to worry about it unless you are one of these examples that needs super performance. But over time things get better and you get them for free. That's the beauty of it. So the more things the language does to fix huge problems, the better it is for everybody. Here is how about the, exactly. So you get the game session, all players, and you map. Done. Now you just wait for this to happen asynchronously, and once you get it, you assign the players. And you mark this as asynchronous, so whoever calls the refresh players also needs to most likely await for it to finish. So it's just a chain of awaits. So it's a sync, and returns the result instead of passing it to the completion handler. Exactly. So this, wait, what? All players. Yeah, all players. Yeah, because here all players was also completion handler. Instead here all players just returns, which is it's what I was talking about before, pure functions and stuff like that. It's a more functional approach, which is always better to understand. And now we can use composition with map, which just does what needs to do properly, and you don't have completions in the middle. It's much more nicer. Explicit self has been eliminated because no scapping closures are, so there is no need for it, and I love it because I work in a code base where I'm forced to put self dot. Even if I'm the boss, I'm forced by the team to put self dot everywhere, and I hate that with my soul. On my own code I never do it, but once you work on a team, it's a democracy, so that's what they want. And yeah, so in there this doesn't apply, but once you work on your own stuff and you don't put self anywhere, look, and with if you start using structs more and more, it's basically the need for this disappears a lot. And then players cannot have data races, exactly, because you're not modifying data in different threads and stuff like that. You're just doing whatever you will do synchronously. It's just that magically it happens asynchronously and you're waiting for it. So queues are used to protect state. The original code was a method on a class that used refresh queue to protect the internal state, yes? This is a common pattern, a class with private queue and some properties that should only access on the queue. We replace the manual queue management with an actor class. Okay. With an actor class. I see now. Actor class. So you change your controller to make it an actor class, which I guess it basically means it can do asynchronous things. Declaring a class to be an actor is similar to giving a class a private queue and synchronizing all access to its private state through that queue. Because this synchronization is now understood by the compiler, you cannot forget to use the queue to protect the state. The compiler will ensure that you are running on the queue in the class method, and it will prevent you from accessing the state outside the method. Yeah, okay, basically. So when you do actor, basically you cannot touch these things unless you go through the proper concurrency systems. Yeah, so it's basically doing this, but the compiler is doing it for you. Okay, that's an easy way to understand and explain. Because the compiler is responsible for doing this, it gives me smarter about optimizing my synchronization, like when a method starts by calling an async function on a different actor. Yeah, I kind of understand that. Basically here, if this is a separate actor, that's the first thing this function does. So basically you don't need to stop the synchronization when you start this function, because it's already going to somewhere else. So you need to just do the synchronization when you when you come back, when you assign it. I don't know. That's cool. That's a little bit of my understanding. Having the static relationship between the actor and its functions and properties let us enforce the isolation of the data and actor and define away data races. We statically know whether we are in a context that can safely access an actor's properties, and if not, the compiler handles switching into the context. Above we show the actor class where you got a tightly encapsulated set of properties and code, but the way we do UI programming today often splits code across a large number of classes that, sadly, they were supposed to use from a single main thread. Sadly again. The main thread is still a kind of actor. It's what we call a global actor. That, makes sense. Yeah. Spreading code, I got so many, that's so bad, but it's so real nowadays. I call this the OP pollution. You can more classes and functions as being tied to an actor with an attribute. The compiler will let you reference this class from anywhere, but to actually call this method, you need to be on the UI actor. So if it was a repeat for all actors of player refresh controller to be to all actions to be performed on the global UI actor, we will represent it like this. So we have the class. And instead of saying that this is an actor which gives it a private queue, we kind of say this is a UI actor with this annotation, which gives it the queue, but it's the queue from the main thread, basically the main actor. Fair enough. Fair enough. I have to see how this... I mean, this is an example, so it doesn't really clarify how this is used. But okay. So, you see what I'm doing? I'm like, there are things I don't know. There are things I don't understand, really. I know I don't understand them. I just move on. Because I know they're going to be clarified, if not on this post, in the future, somewhere else. So I don't worry about it. I have a grasp of it. And if you get stuck and you now start using, but how I'm going to use these and blah, 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 then you focus on the wrong thing, Like, you need to learn everything at the right time. And as long as you know what you're lacking, okay? So right now, I know I'm lacking. What I'm lacking is seeing how this is used, basically, to make a UI application, kind of. Even if a good answer for that will be, well, maybe when we have this, the way we do UI applications changes. That's also a good point. Anyway, moving on. Proposals for the freeze phase. We'll pitch the following proposals in the coming weeks in support of the freeze phase. Oh, cool. So it's crazy time it's coming for Swift Evolution. Async await introduces a coroutine-based async await model to Swift. Functions will opt into being async and then await the results of the async functions, allowing asynchronous code to be expressed in more natural straight line from pitch here, proposal here. Yeah, one of the things I didn't like about the async await, it was that I will kind of have preferred to use the yield function because it's more generic, even though it's right that the async await, it's kind of the common use case. But async await kind of misleading when you are dealing with things like generators and stuff like that, which I'm hoping this also helps with. So these proposals are the old ones, right? So this page is... no, it's also new. Oh my god. Okay. I mean, I'm not gonna take a look at all of these now. Wait, so you have a pitch 16 hours ago? Okay. I thought they made the evolution proposal already. Okay. No, they just have... I mean, it's here, but it's still not running. It's awaiting and stuff like that. Fair enough. Cool. Although, the implementation is interesting because there are some parts of this that are kind of already implemented. That they have been working on it. Task API and structured concurrency. Task API and structured concurrency introduces the concept of a task to the standard library. This will cover APIs to create detached tasks. Task nurseries. Okay, why are we not calling it factories? Lol. I have a friend that is gonna laugh. Wait. What is PR? Task nurseries. That's so fun. This is an inside joke. Because every time we want to make a factory, he comes up with new names for factory because he doesn't like factories, but sometimes we need one, and he's like, oh, well, let's call it Forge. So we have actually Forge in our code and things like that. It's so funny. Okay, so task nurses dynamically create child task and then mechanics for cancellation and prediction of the task. Okay, so it's kind of like a factory, but it also deals with cancellation and prediction. It also introduces scope-based mechanisms for awaiting values from multiple child tasks. So this is like we want to run things in parallel based on principles of a structured concurrency. Okay, I don't think I'm gonna open everything because I need to go back to this. So all of this is first phase. Actor and actor isolation describes the actor model, which provides a status solution for concurrent problems. This provides for foundation for actor isolation, the mechanism through which potential for iteration. Yeah. So actors are the solution for data races, basically. Yeah. So the foundational parts don't solve data races. Adopting actors will. Fair enough. The first phase proposal will introduce partial actor isolation, leaving full isolation front to a subsequent proposal. Pitch here and here. Okay. Concurrent interoperability with Objective-C. Wait, what? Are you kidding? Dude, I didn't thought at all about Objective-C. I mean, it's gonna be super appreciated, especially, I mean, we are kind of 80% or so from Swift code versus Objective-C. Like, we have done a huge amount of work cleaning up Objective-C from our code base. Is it worth it though? I don't know. Convention-based expression of a synchronous function. Which is the convention-based in Objective-C? This will allow existing asynchronous Objective-C APIs to be immediately usable in Swift Concurrency. Fair enough. Yeah, so it's kind of like what they do with throws. Okay. I thought it was something crazier. It's basically what they do with throws, where when they see an Objective-C function that gets like a pointer to an error and stuff like that, they basically rewrite it in Swift to be a throwing function. Okay, fair enough. Async handlers introduces the ability to declare a synchronous actor function as an asynchronous handler. These functions behave externally like a synchronous function, but internally are handled like an asynchronous function. Say what? This allows traditional notification methods such as on UI view delegate to perform asynchronous operations without cumbersome setup. Wait. What do you mean by that? Doesn't make any sense. To declare synchronous actor function. I mean, notification methods on UI table view delegate, it's like, well, it's like, yeah, did select, blah, blah, blah. So what? The did select, what? Can I give you now an actor for the did select magically? And for the table view, it doesn't matter because it's gonna call it as a synchronous function, but internally, what I'm giving it, it's gonna be able to run asynchronously. Okay, so yeah, it's like receiving a did delegate and you open a dispatch async and you do your code inside. Okay, I don't know. But I guess this means that when... I don't know, there's so many questions. Because what, like, it cannot be that the delegate protocol changes now to support this, which will mean that when the table view code calls your delegate, it immediately it's treated as asynchronously and it returns immediately from their perspective. That wouldn't make any sense because that can break so much crap. Like, imagine if you want that to be synchronous. I don't understand. Anyway, moving on. Actor isolation and the second phase. So that's the goal. The system thought which is called actor isolation, both because actors are centrally important to the system and because this is concerned with the primary actor protecting state and being accessed outside the actor. Yeah, so basically an actor, it's like a fortress around your state and and there is no way to access it unless you go through the actor. And because the actor knows how to deal with it, then it's when you get proper isolation. However, actor isolation restricts code even when actors aren't directly involved, when it is necessary for the correctness of the system under concurrency. We intend to introduce these features in the roadmap into phases. First, by introducing the ability to create async functions and actors, and second, by enforcing full actor. Yeah, okay, you said that. The basic idea of an actor isolation is similar to the idea of exclusive access to memory, fair enough, and builds upon it. Ah, cool, okay. Swift concurrency design aims to provide an easy-to-use and composable approach to safe concurrency by starting from the natural isolation of factors and then using ownership. Ah, that's cool, you're using ownership, okay. Yeah, so necessarily they will have to ramp up the ownership work. Basically help the compiler understand ownership of references and stuff like that in order to accomplish this second phase of the concurrency. Yeah, because it needs to understand what you are doing. How are you moving data around in order to do this properly? Oops. That's cool. The problem of factor isolation reduces the problem of ensuring that all ordinary mutable memory is accessed only by a particular actor. This in turn reduces the analysis of how memory is accessed and who can in the free space. We can cut the memory into few groups. Properties of an actor will be protected by the actor. Yeah, fair enough. So unless you're in that private actor queue, you cannot touch it. Immutable memory should select constants, local memory should local variables that's never captured. That's important. And value component memory should share properties of a struct or an enum. Value component memory. Yeah, okay. Because structs are and enums are values, so they are kind of intrinsically safe. So they're already protected. Unsafe memory. Allocation, yeah, well, if you have unsafe memory, it's your problem. It's active when there's able to try to force these abstractions to be used safely because the abstractions are meant to be able to bypass the safe language rules. Exactly. So if you use that, that's you're on your own. We don't want to mess with you. Fair enough. Trust the programmer to exactly. Don't use it if you want to be safe. Global memory. Yeah, so that's classic memory cannot be accessed from any code that holds reference to the data class. This means that the reference to a class may be protected by an actor. Passing that reference between actors explores the property. Yeah, that's a no. They also introduce a reference to classes. Yeah, that's a no. So basically, to go full actor, it's to ensure that these last two categories are protected by default. Yeah. So basically, global, you cannot access global memory, and you cannot access other classes data. This unsafe memory, we don't care. Immutable stuff, it's already handled, and properties on an actor will already be handled by the first part of the phase, the free space, basically. Cool. So free space is this. This we don't have to do anything, and second phase is global memory and components. So they will introduce a way for you. That's cool. So they will introduce a way for the compiler to tell you that you're accessing global memory and that you cannot do that, or that you're accessing other class memory that is unprotected because you're going like outside of an actor. That's cool. Okay, so free space basic actor isolation. The free space introduces safety. Users will be able to protect variables with global actors. Okay, so you make an actor and now your stuff is protected. And frameworks can define a global actor and default protocols to it. Oh, that's cool. A number of important classes. So you have an actor, so now all this crap is protected. This will be protected by default, but now the access to the array is protected. So if you give me another actor, an actor can access its internal state even in an extension. I mean, yeah, like, fair enough. Allowed immutable memory can be accessed from outside the actor. Ah, this is another actor, so I'm accessing the other actor immutable memory. That's cool. An actor cannot access, yeah, so you cannot mutate that array. So fair enough. So see, if you say actor, now this stuff, you cannot mutate this from the outside. That's cool. Unless you go through the actor. Ah, and you cannot read or write. Basically, so this is kind of private, but for some reason you still can see it. Allow it async functions can call async, yeah. And you can wait on this. Only asynchronous functions can be called outside the actor, so you cannot call a synchronous function on the other actor. Yeah, because that will kind of block your thread. Interesting. These enforcers are not source breaking because Harton is in function on a new feature, yeah, of course. And now when we say full actor isolation, even after there will be accessibility or race condition through global variables. Yeah, basically, so during the free space, if you don't use global variables or you don't access or you don't pass references around, you are safe. So it's not that bad. Like we don't have to wait for the full thing to be done to be like pretty much safe. Yeah, that's cool. Yeah, so these are racy global. This is not gonna let you unless you do this. Yeah, I can understand. Plain old class. This is unprotected. Take class. That's cool. We intend to preserve Swift current default behavior. Global variables and class, component memory, and not protect. Yeah, because that will be kind of a breaking change, so it makes sense. The default for this memory, because this is the default conversation and interface is not, yeah, bad enough. The second phase, introduction of further features, will provide a full set of tools of work. Okay, so there are things that they still need to introduce that will help, like basically make this change easy for everybody. The most important of this is the ability to restrict a type to be an actor local. When a type is marked as an actor local, the compiler will prevent it from being passed between actors. That's cool. Okay. Instead, the reference will need somehow cloned and shared before. Yeah, that's cool. This in turn will allow the defaults to be changed. Global variables will be required to protect it by a global actor or mark it as actor unsafe. Okay. Classes and types that contain class reference will change from being actor unsafe to being actor local. By default, being actor local. Okay. The change in default is necessary. A source break. Yeah, that's fine, man. Just break the source. Like for these things, like you need to do it. Don't be shy. Code that changes mutable global value, shares a class reference across. And we need to change to ensure it safe. It is expected that the use of global variables should be sparing, and most global variables, yeah, as long as classes are not shared across actor boundaries. This one is well, I mean, it will be a problem if classes now became actors, but that's not how it works. So for new actors, yes, be careful what you do from the start, and that's kind of it. Where reference will be passed across boundaries, the language should make this obvious and the solution simple. True. By furthering the simplicity, the need to share a class. Yes, exactly. So if you encourage and simplify the use of value types, then the default from an existing language it's already safe. So you don't have to share classes across. That's cool. The time between the two phases will give us an opportunity to factor their code. Okay, yeah. Yeah, so it's probably gonna be Swift 6 and 7 or 7 and 8 maybe, who knows. Unlike the pitches for the free space, which will be pitched and proposed, the language features needed for the second phase will initially be raised for discussion on the evolutions discussion section. One of the main drivers for the two-phase approach is that of wanting to give Swift users time to become accustomed to async functions and actors before moving to a full isolation model. Makes sense? Makes sense. It is expected that the experience of porting large working code bases to actors and async functions will inform the functionality and force a full. Yeah. And hopefully community gains enough experience to kind of like realize if the design of the second phase could be improved, basically. Yeah. Features expected to be discussed as part of the second phase are actor local restrictions, compiler support for guaranteed correct copyright types being mutable if unique class type. It's cool if they could make copy and write easier to adopt in custom code. Attributes to opt out of actor isolation. Okay. And here it's some glossary of things. And that's it. Okay. So I was not expecting this to be long. When I saw 51 messages, I thought this was basically shorter. Okay. I thought I would have more time to get into the comments and take a look at what the first impressions are, but I think I'm gonna leave it here. So of course there is this list here. Where is it? Here. So the next steps will be to go through these proposals that are already there and wait for these ones to show up at some point. Yeah, but I'm gonna do that another time. Cool. So yeah, I don't know what you thought. If you are still here, thank you for watching, and if you have any comments or concerns, you can find me on Twitter on Alexito4, or you can leave a comment if you are watching this on YouTube, just down below. Thank you very much for watching, guys, and see you next time.